Good day, viewers. Welcome back to my YouTube channel. You're welcome to Master Builders Online Academy, the only online academy where the tips and the mysteries behind engineering problems are today. So, in this video today, I'll be holding you again by the hand and teach you the principles behind problem solving in fluids. No lies. I will hold you by the hand and teach you step by step the methodology, the principles involved in solving problems in fluid mechanics effectively. No lies, not at all. Now, guys, listen. Have you wondered how people solve problems in fluid mechanics, in solid mechanics, in soil mechanics effectively without stress? There is something they know that you don't know, and that is what I'm here to show you. So please do not skip any part of this video. If you will be able to take advantage of these mysteries, I will be unveiling why I solve selected problems in solid mechanics in your favor. So what you need to do is to avoid every unnecessary distractions and ensure you pay close attention to whatever principle I will be unveiling here. Remember, our mission is not to solve thousands of problems, but just to solve a simple problem that will empower you to solve as many problems as you have in line with that question. Now, remember, all problems under a particular topic are solved the same way, only that you need to understand the principles. That is all about it. So, without wasting much of our time, let's jump into the marker board and start looking at the basic problems in engineering mechanics. Now, guys, on the board we have problems and solutions in engineering mechanics. This is problem 7. Remember, this is a continuation class on this course. Find the moment of inertia of a T section about S, S, and Y, Y axis through the center of gravity of the section as shown below. Now, this is the T section already given to us. And from the basic idea, we know that T section is a composite section, which is a combination of two rectangular sections, right? Which one is portrait, then the other is a landscape. And meanwhile, you understand very, very well that these two shapes that are combined together to give us a T section are rectangular sections, for which their geometrical properties are easily remembered, right? So you know their geometric properties such as the length, the breadth, the area, the volume, as the case may be, the center of gravity or the centroidal axis. All of these are very, very easy for you to obtain when it comes to what a simple section such as rectangular section, triangular section, cycle, semicircle, name them, just plain shapes. All right. So when we have a T section as we are asked to find the moment of inertia. So to obtain the moment of inertia, the first thing that you need to obtain or to assess is that you need to know whether this section is symmetrical to either x-axis or y-axis. Now, guys, without wasting much of our time, T is a section that is always symmetrical about y-axis. What do we mean when we talk about symmetry of any composite figure? If, for instance, this is a T section that we are given, right? This is what we are given. If I divide this into two equal parts in the y direction, this is y-axis. What I have to the left-hand side is equally what I have to the right-hand side. So because what I have to the left equals what I have at the right, that makes this section to be symmetrical about y-axis. Take for instance, we want to ascertain if this section again is symmetrical about x-axis. We just take anywhere we think it could be the center, then we draw x-axis. So when we look on top of this x line and look beneath, top and bottom, you will find out that what you have on top of this axis x is different from what you have at the bottom of this axis. So therefore, this section is not symmetrical about x-axis, but only about y-axis. Now, because this t section is symmetrical about y-axis, the centroidal axis of this section will lies in y direction. So as a result, we will be looking at the centroidal axis parallel to the base. Are you there? So how do we get to do this? The first thing we will do is to what? Obtain the first moment of area or the centroid of this section. How do we get to obtain that? What we need to do first, guys, is to see how we can section this into recognized or notable shapes. Like we have it, this is a T section, and as it is, we don't know whether this is a rectangle, we don't know whether this is a rectangle, but by standard, we know that by the time we join this line to this end, these have given us a closed rectangle, these have equally given us another rectangle. Therefore, we will now take our reference line. How do you take your reference line? Reference line can be taken from the bottom or from the top. But as far as this class is concerned, or this lesson is concerned, we will be taking our reference line from the bottom, since we have identified that this section is symmetrical about y-axis. So we will take our reference. Let this bottom surface be our reference line. So as long as we have gotten our reference line, whatever we are doing on this figure must begin from this reference line. So now that the bottom surface of this T section have been taken as our reference line, therefore we have that this guy becomes section 1, while this other guy becomes section 2. Now, what do I need to do to section 1? And what do I need to do to section 2? Now that I have classified this T section into two different notable sections. What is obtainable in each of these sections include the area of each section and the centroid of each section that lies in y-axis, because the section is symmetrical to y-axis. So what do? We need to find the area of this and equally find the centroid. We need to find the area of section 2 and equally find its centroid. So now, how do we go about finding the area? As long as we know that this shape is rectangle, we will use the area of a rectangle to obtain the area. And as well, we will equally use the area of a rectangle to obtain this area. Now, how do we go about the centroid? Because, of course, before we can get the center of gravity of this composite section, the principle required us to first of all obtain the centroid of each of these sections. So, all we need to do is to get to this edge and connect it to this end, which is the diagonal. Connect another diagonal from this end. The point at which the two diagonals meet is actually the center of gravity. Then, let me assume that this is the center of gravity. This is where the two diagonals will meet. Alright? So, if this point is where the two diagonals meet, all I will need to do is to take out a line, a horizontal line, parallel to this reference line, then call it y1, which is the centroidal axis for section 1. The same thing I will do for section 2. I will take from this end to this end, get a diagonal, take from this end to this end, get a diagonal. The point at which they meet will be somewhere here again. Then you will take a parallel line out, dimensional line, which will be parallel to this reference line, and then we will call this y2. Same it is when you have more than two sections. Now, everything must begin from the reference line. Now that this is achieved, what next do we take? All we simply need to do is to start taking these sections one after the other. Now, what do we have? For section 1, we will find the area 1 and y1. So what will be the area of section 1? The area of section 1 will be what? The length times the breadth. And it happens that the length is 150, while the breadth is 50. So we have 150 times 50. And when we multiply this, this will give us 7,500 mm squared. Now, what do we do about the centroid? When you have a rectangular section this way, now the centroid of a rectangular section is half of the vertical distance, since we are looking for the vertical centroid. Are you there? So we'll quickly get half of this centroid, half of this vertical length or vertical distance of this section will give us the centroid. So we'll quickly have 150 over 2, and that will give us 75 mm. This is the centroid or the properties that we need to obtain for section 1. Now we move to section 2. For section 2, we will equally obtain area 2 and y2. Now the area 2 will be the area of this section, which will equally be what? 150 by 50 length times breadth. 150 by 50, and this will equally give us 7,500 millimeters squared. Okay, now what about the centroid? This is where you need to pay a very close attention. One of the principles that will help you effectively solving problems on this category of engineering techniques is what I'm about to reveal now. Look at it carefully. Remember, when we started solving this problem, we had a line of reference, which is the bottom surface of this T section. So every journey that we have begins from this reference upward, right? Now, having known that we are looking for Y2, remember that Y2 started from here to the center of the section 2. Right, correct? Yes, from this reference line to the center of section 2. This is the central 2. Now, how do we get this value of Y2? Now, first is that remember that this section 2 does not have a direct contact with the reference line. Are you with me? There is a space or a separation between section 2 and this reference line. So that separation, that gap between this reference line and this section 2 must first be noted. So now if I ask you guys, what is the reference, what is the separation or the gap between this reference line and section 2? I know you can do it, so check. What is it? Now, the separation between this reference line and section 2 is 150. In other words, before you will get to section 2, if you begin your journey from the reference line, you have to pass a distance of 150 before you get to section 2. So that distance you covered between the reference line and section 2, you put it down, and that becomes 150 plus. Now that you have considered the separation between the reference line and section 2, then you can now take half of the vertical distance of section 2. Are we there? Something very simple. So, what's the vertical distance of section 2? 50. Now say 50 divided by 2. And when we divide 50 by 2, this will automatically give us 175 mm. Now that we have obtained these values, what else do? We will now go ahead to obtain the centroid, which is the same thing as first moment of area. And this centroid we are obtaining is the centroid parallel to the base. Are you there? So we can say centroid parallel to the base or centroid. What? So centroid, the axis parallel to the base, and the centroidal axis parallel to the base is SX. So in that case, you have Y bar is given as A1, Y1 plus A2, Y2 all over A1 plus A2. All we just need to do is to put in their values. That's all. So the value of A1 has been computed to be what? 7,500, while the centroid is 75. Then we have 7,500 multiplied by 75 plus the area 2 is given again as 7,500 multiplied by the centroid is 175 all over the sum of the two areas. Then we have 7,500 plus 7,500. And when we compute this with the help of our calculator, our answer becomes 125 millimeters. We have successfully obtained the center of gravity of this section. So what we'll do is we'll come somewhere here and measure 125. Remember that the overall depth of this section is 200 From here to here is 150, and from here to here is 50. So when we add everything together, it shows that the height of this thing is 200. Are we there? So now we will just measure 125 from this bottom, and maybe it could be somewhere here. So this is where you have as your y bar. Now, assuming you took your reference from the top, this is what you have obtained from here to this point. Y bar C compression, right? Why this guy is in tension. So now that you have obtained this, to obtain the one from the top is just to remove the value you have 125 from the overall height of T. If you remove 125 from 200, you will exactly have 75. That means the centroidal axis of this section from the top would have given you 75. Mind you, whether you take it from the top or from the bottom, you will have the same second moment of area. Okay? Now, if this is clear, what is the next thing? The next is to now obtain the moment of inertia, which is the same thing as second moment of area. Guys, am I opening your eyes already? Are you beginning to gain values for this lesson? Or are you excited that you are learning these mysteries for free? You have not learned anything. Let's continue. Okay, now, at this point, the next thing is what? We come to the question, moment of area of inertia about T section of X. So, moment of inertia about X axis, and this is given as ISX is equal to, now, because we have two sections here, we will equally obtain the second moment of area or the moment of inertia for each of these sections, then add them up. Remember, the same way we obtain area 1, y1, area 2, y2, the same way we are going to obtain the moment of inertia for section 1 and the moment of inertia for section 2, then we add them together. So because of the space of my board, I will put it in an equation form as Ixx1 plus Ixx2. This I will call equation 1. So what I need to do now is to obtain Ixx1 from section 1. Remember, from section 1. Simple as that. So I have Ixx1 will be equal to B1 D1 cube over 12 plus A1 into Y1 minus Y bar all squared. This is the formula. So when you look at this equation, you find out that we have B1 D1 A1 Y1. The only difference is the general centroidal axis of the CT section. So it shows that all these ones that are carrying subscript 1 must be taken from section 1. Hope that is clear. Everything here taking subscript 1 must be taken from section 1. Now, another beautiful thing you need to understand between B and D is that B is the horizontal distance of the section, while D is the vertical distance of the section. I come again. B is the horizontal distance of the section, horizontal distance with respect to X, or distance in S direction, while D is distance in Y direction, in vertical direction. So this is how you get and capture your values from the figure. I hope this is blowing your mind already. I hope you are beginning to gain value from this mind-blowing session with the master builders. Don't worry, you have a lot to learn. So all we need to do is, what is B1? We'll come here. The horizontal distance of section 1 is 50. Multiplied by the vertical distance of section 1 is 150. All over 12. Plus area 1, already calculated for. Area 1, 7,500. Into Y1, already calculated, 75. Minus 125, which is Y bar, already obtained, all squared. Then, guys, when you put these values into your calculator, what you have is 32.8 times 10 raised to the power of 6 and raised to the power of 4. This is the SI unit of second moment of area or moment of inertia, power of 4. Now we have successfully obtained this moment of inertia for section 1. Now let's obtain that of section 2. Then we combine them together. That's all. Now, I x x2 will be b2 d2 over 12 plus a2 into y2 minus y bar all squared. So in this case now we now have substitute all true except for the y bar, which is the centroid. Now we put in the value. Remember, these values, the value for b2, d2, a2, y2 must be taken from section 2. Those substitute test the section from which the values will be taken. As simple as that. Right? Now what do? When we come here for section 2, this is the horizontal distance, because I told you before B is the horizontal distance, which is 150. And the vertical distance of this section is 50. 3 all over 12 plus area 2 is 7,500 into y2 is 175 minus 125 is the power of 2. And if we multiply this and simplify, our answer would have been 20.3 times 10 raised to the power of 6 and n raised to the power of 4. This is the answer to the moment of inertia for section 2. So how do we now get the second moment of area or the moment of inertia for the T section? We now need to add up the two values together using equation 1. So substituting into equation 1, we have that I x is equal to 1 is 32.8 times 10 raised to the power of 6 plus the other is 20.3 times 10 to the power of 6. All in n raised to the power of 4. So by the time I add this, just add the values together. This plus this will have given us 53.1 times 10 to the power of 6 and n raised to the power of 4. This is the second moment of area about SX axis. Guys, is this not simple? Is it not simple? Very, very simple. So simple. Okay, now let's look at the second moment of area. Remember, we are looking for second moment of area on the moment of inertia about SS axis and equally about YY axis. So for the YY axis, let's look at that shortly. I moment of inertia about y axis. So I y1 will equally give us I y1 plus I y2 y2. Why? Because we have two sections. So we are going to obtain the respective moment of area or moment of inertia for each of these sections. So we will add that of section 1 to that of section 2 to get the moment of inertia about y axis. Now, one of the things you need to understand about this y axis is that as long as the section is symmetrical about y axis, remember that the centroid about x is equal. In other words, x1 is equal to x2 and x2 is equal to what? X bar, which is the general centroidal axis. So in this case, to obtain the value of second moment of area, this part that we have for xx will no longer exist for y. Naturally, this is what we're supposed to have. I y1 would have been equal to b d1 2, okay, 1 all over 12. In this case, this will now take the cube. Then plus a 1 into x 1 minus x bar squared. This would have been the model we will use or equation we would have used to solve for I11, similarly for IYY2. But we are not going to make use of this part because this x1 is equal to x2 is equal to x bar, and everything is equal to what? The highest value of x divided by 2, which is 150 over 2, and this will give us 75 mm. What it means is that the value of x1, if you calculate for it, it will give you 75 mm. The value of x2, it will give you 75 mm. And the value of the mean, which is what the centroidal axis, it will equally give you 75 mm. Now, take it clear. If we put 75 here, minus 75, everything inside the square root, inside the bracket, would have given us 0. When you square 0, it will give you 0. When you multiply 0 by this area, it will still give you 0. So that makes this part not important when solving for IYY, when you know fully well that the section is symmetrical about y-axis. I hope this is gotten, but if not, we will solve other questions when your eyes will be more open to more mysteries. All right? So in this case, we will obtain this. So in this case, what will become the value of this? This becomes B1 D1 over 12 plus B2 D2 over 12. In this case, like, the easiest way to have this done without stressing yourself is that now that we are looking for IYY, it shows that you will now put your Q for B. Remember, when you were finding ISS, you were cubing the vertical distance. But now that we are finding IYY, we now need to cube the horizontal distance. This is how the measures. Okay? When finding ISS, the vertical distance we cubed. But now that we are finding IYY, it is the horizontal distance that will now take the cube. If this sinks into your head, then I deserve a kind of applause. Then we have this as Q. It's as simple as this. What do we need to do? All we simply need to do is to put in the value of B. Just come here, you don't need to stress yourself. Here, this is what you have. This becomes 50. Just swap the power. Just put the power here. Swap the power. Then this is 150 all over 12 plus. Come here again. You will now cube this. That would have given us, we are cubing 150 down. 150 cube into what? 50 over 12. I hope you understand what I've done so far. This is it. So by the time you simplify this, add them up together, your answer will have been what? 0.62 times 10 raised to the power of 6 and raised to the power of 5. So this is your IYY. Now guys, this is what this question requires from us. That we should obtain the moment of inertia about x-axis and about y-axis. So as simple as it is, it's just like this. So very quickly, we'll be solving another question. But please guys, if you are here to subscribe to this YouTube channel, it will not take you anything, alright? It will not take you anything. Please subscribe to our channel for these massive values you are gaining from video. Please encourage us by subscribing, share this video, and ensure that you like this video. Please guys, thank you for watching. See you in the very next question. Number 8.